AS-Level Trigonometry Exam Preparation Questions Part 5. It will also be the last part in this topic. Let's look at trigonometric graph sketching. You will find this on page 160 in the grade 12 AS-Level Mathematics textbook, y equals mx plus c. Before I start, I just want to maybe explain the table a little bit more because it can really help you in curve sketching. So if I look at this, I think it's the best to start with this formula. So if they say y equals a sin bx plus c. So let's just take an example. I'm going to take an example. Y equals 2 sin 3x plus 4. Now, it's always good to first recall the basic or the graph, the basic graph. And I'm just going to write it here for you in green. As I said, you must memorize that basic one. So the basic one just starts there. Okay, my graph is not working nice. So it starts there, it goes up, it goes down. So there is 360 or 2 pi. And it's there at 1, and it's there at -1. Are you with me? And there is a 180. Okay. Now, if I must draw one like this, I must remember a few. The amplitude in this case was 1, but now the amplitude becomes 2. Then, if I look at this period, in this case it was also 1, but now it becomes 3. And it shifted up vertically 4 units. Okay, if it was negative, it would have shifted down. Now, let's look at this table, how it can help me to create a graph like this. So, let's start, for example. If I want to find this new one, I want to find the maximum value. What will I do? I will say, okay, remember, can I just show you? This is A, this is B, and this is C. Okay. So if I want to find the maximum value, I'm going to say A plus C. A plus C, so 2 plus 4, and that's going to be 6. If I want to find the minimum value, it's going to be negative A plus C, so -2 plus 4, and that is going to be 2. Okay. If I want to find the period, it means when the graph is starting to repeat itself. Then it's 360 divided by B and 3, so it's going to repeat every 120 degrees. Okay, and if I want to see where it cuts the y-axis, the y-intercept, it's going to be C, and in this case, it's going to be 4. So if I must now go and I must draw that graph, so let's do it and let's just draw it. I just want to see, okay. So I'm just making it nice now. Okay, I just want my units also. So let's see if I think it's maybe a bit low because it's moving up. Okay, so what is the minimum? The minimum is 2. And what's the maximum? The maximum is 1, 2, 3, 4, 5, 6. I think I can move the computer screen up a little bit. Sorry. Okay. So let's just move it up. So basically I can mark already the points. I can now say for example this is 360. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let's make this 360. So that means 12. So every 3 is going to be 120. Okay, every 4. So 120. And then 1, 2, 3, 4, and this is 240. Okay. And then I can also go and I can mark my minimum value. It will be 2. Okay, I'm going to now. My minimum value is going to be 2. And my maximum value is going to be 6. 1, 2, 3, 4, 5. It's going to be there. Okay. And it's going to, the y-intercept is because it's going to be in the middle, and the middle there, it's going to be 4. Are you with me? So there's 4, there's 2, there's 6. So the graph is going to be there. So basically, I can, because I know, if I go back, I know the sin graph starts in the middle there. So it's like I have this picture in my mind when I'm doing it. And don't forget that I must make a complete revolution here. So let's just have that picture in our mind. And it's just going to turn there. So let's just going to see. It's going to be something like this. And this, okay. Do you see? Okay, my curve is not nice enough, but okay. So basically, and then I just continue this pattern. So it's going to be like this, like this, like this, and then it's going to be there again, sorry. Like I could have marked a few points in between. It would have helped me a little bit with the curve sketching. But this is the sketch. So by using, I just showed you, by using this table, it can really help you. So if that's the period, what was the period? 360, it was 120. Okay, now that is just how I use the table. I want to show you another one. I want to show you also a cos one. So I took this and now I'm going to take, say, a cos one. Okay, so let's clean again and let's take totally a new one. Okay. So which one do I want to take? I'm going to take y is equal to 3 cos a half. I make it now a fraction. And now I move down 2. Are you with me? Okay. As I said, I always prefer that you have the original sketch in your mind. So y equals cos x. How does that graph look? A nice sketch. And this is not nice, so nice, but it's like this. There is 360, and it's starting there at 1, and the lowest point is -1. That must be in your mind. You must memorize that. And now you can work towards this one. So now I can say the maximum value, and I'm now here. I'm going to let this help me there because it's the fraction. So it's a plus c. Okay, don't forget again what I said. This is a, this is b. Grab that sign, this is C. Okay, so the maximum value will be A plus C. Okay, so A plus C. So it's going to be 3 minus 2, and that's going to be 1. The minimum value is going to be almost the same as the negative A plus C. So that is going to be -3 minus 2. And that's going to be -5. And now, remember, due to, I showed you there, you multiply by b. So the period is going to be 360 multiplied by b, and that's going to be 180. So it's going to stretch out. It's not going to shrink in like that free waves that we made. Now it's going to be just half one in 180. And then the y-intercept is going to be, now where is the a plus c? So a plus c, so 3 minus 2, and that's going to be 1. Okay, so let me start with that sketch. So if I'm going to now, I just want to make it not so that I can still see all the values at least. I would love to see the curve also. There, okay, so let's see if we can have all that info in. This one is moving now a bit down again. Oh. I prefer working with a ruler here. Okay, so it's going to 5. So 1, 2, 3, 4, 5. I think it will be right there, and it's just going to 1. So I think this will be fine. And I'm going to do again. So what we said, we're going to say it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can make that 360 again. 360 degrees. Okay, so the half will be 1, 2, 3, 4, 5, 6. So that will be 120 degrees. Okay, there is 1, and then it's negative 1, 2, 3, 4, 5. There is negative 5. Again, it's good if you mark a few things. So this graph is going to start there. Also, the y-intercept is 1. It's going to make a turn. It's not to say it's going to do, but now remember, first sketch, you remember that graph. So basically, that whole graph, it's only that part that I'm going to draw. Okay, so if I must really go, it's going to make the turn there. So it's going to be a bit challenging, but I'm going to try my best. So it's just going to be something like there. Okay, it's actually making there at the 5. Maybe my turn was just a bit too early there. And I could have gone down, 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 and there. After there, sorry for that, it would have started going. Okay, and that's how I sketch that. So really let this table help you. When it comes to the tan, and the reason why I want to show you just quickly, if it comes to the tan one, because before I start with the examples, if you have the tan one, say tan, don't forget y equals tan x. So if you draw the tan one, though, I draw a lot in this videos, so then you would have seen that, okay, let's rather make it like this, sorry, a bit too rough. And then it was at least 4, 1, 2, 3, 4, and then 2. But if you was the tan one, can you remember it was like this, and then it was like this, and then it was like, say, this, up to 180. Okay, so the problem is, you because it's striving to that axis, it's undefined, or it does not exist. It's going up, 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 up. So there's not a maximum, and this one is going down, 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 and it's not a minimum. So the only thing that you can actually determine, and you do it like the sin and the cos, is the period. If this graph is going to stretch out, or if it's going to shrink in, if it's going to make the repetitions faster, or if it's going to make it slower. That's actually basically what you can do. But you can always make a small table, plot a few points, and that will also help you with this shape. Okay, let's start with the example. Let's look at example 5. The equation of a curve is, and I'm going to underline it, y equals 3 cos 2x, and the equation of a line, straight line, is 2y plus 3x over pi equals 5. State the smallest and the largest values of y for both the curve and the line from x is bigger than equal to 0 and smaller and equal to 2 pi. Okay, so let's start. If this is the equation y equals a cos bx plus c, as I showed you in the table, then y is 3. Okay, so a is 3. What did we say? A is 3, b is 2, and c is 0. So to find that maximum value, and we can go back, can you remember how we said? To find the maximum value, okay, so it's going to be a plus c. Okay, so it's just a cos. So it's 3. The minimum value is negative a plus c. So it's negative 3 plus the c. The c is 0 in this case because there is not standing anything. It's plus 0 basically. Okay, so in the curve, the largest value of y is 3 and the smallest value of y is negative 3. Okay, now in the line, it's a straight line. So basically, I will take these 2 points and this point to see what is the beginning and the end of the line, straight line. So if I substitute I take in the place of x 0, then this becomes 0 and 2y equals 5, divide 2 and y equals 2.5. And if I substitute 2 pi, okay, then 2 pi, and then the pi's cancel, and this is 6, so, and then 6 is going over and it's becoming negative 1, and if I divide 2, it's negative a half. So the largest value of the line is 2.5, and the smallest value of the line is negative a half. Now, sketch on the same diagram the graphs of the curve and the straight line for this. Okay, so now if I want to sketch, so just remember, as I said, this is actually, just remember, if you look at this, it will go from 3 to -3. And because it's 2, so I can maybe just a period, maybe I showed you here. So the period is going to be 2 pi divided by 2 pi. So it's going to make a complete turn, revolution in 1 pi. Okay, so recall the general cost curve. Okay, so basically, as I showed you in the general cost curve, so there is 2 pi. So it will make a complete one until pi and another complete one until 2 pi. And then I just plot the 2 points, 0 and 2.5, and 2 pi and -1/2, and I just draw the line. And that's how I do it. Not really that difficult. So make use of that table just to memorize how to find the maximum, the minimum, and what everything in the equation is standing for. Okay, let's see. State the number of solutions of the equation. Just see how many times it intersects. So it's 1, 2, 3, 4. So it's intersecting 4 times. So to put the two equations equal to, okay, can I just show you here? Because if you look, just because it's just not, I want to just show you. The problem was that this one was y, and this one was 2y. So if I was writing this, I could have said 2y, 5 minus 3x over pi. But then I must just, to put it equal to each other, I just multiplied by 2 there. But it doesn't matter how, the end it can just go higher. It will still be, I just showed you, to put it equal to each other, it will still have 4 solutions, 4 times intersecting. Okay. And that's how we do it. So because if it's becoming 6, then it will just go from 6 to -6. Okay, let's see what I want you to do. I want you to stop the video and I want you to do all 3 questions, but I think let's do it like this. You do one, you check the video, you see if you are correct, you do the second one, you check the video, and you see if you are correct. Okay. Let's start with question number 1. The diagram shows part of the curve with equation, and there they give you equation, where P and Q and R are constants. Okay, so basically, there is the curve. So if I look at the maximum point, it's 1, and if I look at the minimum point, it's -5. Can I just go back to the previous page and just show you? If you must find this amplitude, you know this amplitude was 3. Can I show you here? This amplitude here was 3. But if you want to see it from the graph, you would have just say, okay, I take the maximum and I subtract the minimum. So it was the maximum minus the minimum, and then I just divide it by 2. Let's just see. So if it's 3, subtract -3, divide 2. So it's 3 plus 3, which is 6 divided 2, which will give me 3. Okay. So let's do exactly the same. If we're going to say number 1a, the maximum minus the minimum divide 2. So the maximum is 1 minus the minimum, -5 divide 2. And that's going to be 1 plus 5 over 2. And that's going to be 6 over 2, which is also going to be 3. So therefore, the value of P, because that's in front of the sin, is 3. Okay. State the value of Q. Let's just see where is Q. Okay, this is number B. Sorry, I'm not writing it nice. Okay, let's make B, and I'm looking for Q. So where is Q standing? So basically, I can just see it's 4 pi. Did you see that? So it's almost like you can say, to find 4, it's 4 pi B, but I know a normal one is 2 pi. It's basically, I just want to see, did it stretch? Because if it's stretched out, then it's a fraction. If it's going in, then it's going to be a constant, bigger than 1. But in this case, I can say 4b if I want to do it on a method. So I can already see it's stretching out. But if I cancel, so I will find the value of b. What is the value of b? That's going to be a half. Okay, because a normal one would have only go up to there. And then the last one, state the value of r. It's to see how many units did it shift up or down. Now I can look at the middle point here. Now can you see if the middle point was on 0 and it shifted down? Did you see there? It shifted down 2 units. Okay, so then I can say, okay, so basically it shifted down 2 units, so the value of r will be -2. Just make sure, it's really just thinking a little bit logical, looking at the graph and find the values. Okay, so let's do number 2. So that was an easy one. And they love asking this very basic ones also in the exams on graphs. Okay, so this one, the diagram shows part of the curve, okay, and there is the curve, do you see there, where x is measured in radians, okay, and a and b are constants. The curve intersects the x-axis there and the y-axis there, okay. Find the values of a and the value of b, okay. Now, let's just number 2. I want to make it a bit smaller so that I just have a bit more space to write. Okay, and the color is also for me not clear enough. Okay, so let's start. So the equation with the unknowns is here. Now, let's see. The 2 points that I have 0. So I have the 0 and 3, that's the y-intercept, and then I have the x, which is -1/6 pi and 0. Now, if I look at this one, because if I can already find y, if I can find a, if this is just becoming 0, so then I must substitute in the place of x a 0, which will work in that case. So if I go and I say y is equal to a plus tan b, and I put a 0, then I get y. Okay, I forgot to put y in. Let's just put y also in. It's supposed to be in here. So there's the y. So it's square root 3 equals a. So square root 3 is equal to a. So therefore, I already have now a. That's good, because now it can help me in this one. So if I start again with the formula, y is equal to a plus tan bx. Okay. So now, this is again, can I just show you? I want to take another color. This is x and this is y. Okay. So now, in the place of y, I'm going to substitute a 0. So okay, let's just do that. So y is 0. I have a, I can put it now in, plus tan b, and I put in x, minus 1/6 pi. Basically, I'm putting it in like that. Okay. Now, if I want to see, so let's just see, if I bring this over, I'm just going to simplify. So it's -3, and that's tan b, -1/6 pi. Okay, now if I want to see, first leave this, I just want to focus. Can I show you? I want to just focus on this part, getting rid of the tan. Okay, so it's almost like I will press second function, but I'm going to do it with the special triangles. So if I do it with the special triangles, can I just show you? This is my special triangle, which I construct here. Remember, it's always coming from the equilateral triangle, so that's why it's 2, and this is the half of 2, 1, and this is square root 3 with Pythagoras theorem. Now, this was 60 degrees, but I remember it like this, 6, but then it's pi over 3. This was 30 degrees, so this one will be pi over 6. And this one was pi over 3. Okay. Now, if I look and I see, first leave there, and I just leave the negative, and I see, Okay, square root 3 over 1. Focus there. So if I say tan must be opposite. Are you with me? Opposite over adjacent. So from what angle did I work? Can you see? If this is going to be opposite, because and this is adjacent, then I worked from this angle. So I can basically go with this blue or yellow. I can just say, okay, then B, don't forget, this is almost like just a constant traveling along, is equal, so opposite, so it's going to be pi over 3, but keep the negative. Okay, are you with me? And now I'm just going to simplify that. So now I'm going to, because there's a negative and a negative, so it's going to become positive, but I'm going to divide by negative 1 over 6 pi. I divide negative 1 over 6 pi. So I get that B, okay, the negatives will cancel out, but this will be pi over 3 multiply. Remember, this is actually pi over 6. So if I take the reciprocal, it's 6 over pi. I can still go with the negatives and then get it out now. A negative times a negative is a positive. So this cancel, and this is just going to become 2. So I got that the value of B will be what? It will be 2. And that's how I did number 2. So just stay focused a little bit. I'm using this special triangle. And don't get confused. It's almost, I would have said, I wonder if you were putting this, it's this in front here. It's almost like, you remember you got, say it was that 2x, say it was tan. I'm just using an example as an explanation. Say you had tan 2x and then whatever. Okay, say 0.5. Yeah, let's make it 0.5. And then you would have first get your tan with your calculator, and then you would have had 2x equal the angle, and then at the end you divide by 2. Okay, are you with me? And this is the same. So this is almost like that 2. So you first get your tan, first get your shift tan, get the angle, get the tan away, and then at the end you divide by the negative 1 over 6 pi. So see it in that light. Okay, then you're going to have it correct. Okay, so let's start with question number 3. Functions f and g are such that fx equals 2 minus 3 sin 2x, and x is bigger and equal to 0 and smaller and equal to pi. And gx equals negative 2fx for x bigger and equal to 0 and smaller and equal to pi. Okay. State the range of f and g. So if I look at this one, I'm going to start. I'm going to say number 3, fx. And that's equal to 2 minus 3 sin 2x. Now, they write it like this due to that negative there. But I think if you rewrite it like this, it's going to be more in the format that you will know. So this will then be my value of A, this will be my value of B, and this will be my value of C. Okay. Now, what does this negative in front of the amplitude mean? This means that in a normal graph, if it will first go up, okay, if it's negative, then the graph will go a reflection in the x-axis, and then it will first go down. It must just start there at 0. Sorry, my sketch is not so good. So instead of going up first, this one will just first go down. Did you see there? Okay. So this is going to be a reflection in the x-axis, but still, and this can make the points minimum and maximum. So I'm going to rather write it like this, and I'll show you now why. But still, for the one, it's going to be A plus C. And for the other one, it's still going to see the extreme points, the biggest, the largest y value and the smallest one. It's going to be negative A plus C. So if I do this one, it's going to be negative 3 plus 2, and that's going to be negative 1. And if I do this one, And that's going to be 3 plus 2, and that's going to be 5. Now, why did I call this minimum maximum? Because actually, can you see, this one gives me, due to the reflection, now the minimum, and this one is the extreme point. This is going to give me now the maximum. Okay, I can already write it down. I can already say the range of fx. So the y values, so fx is going from -1 up to 5. Are you with me? So basically, if I look at the sketch, and I'll come now to the sketch, I can already see that this point is there, -1, and that extreme point there is going to be 5. I'll come now to that. Okay, let's do number G. So if I now go and write G, now look what G will be. G will be -2 and then fx. Okay, let's just write it down. Let's write fx down. 2 minus 3 sin 2x. And that's going to be -4 plus 6, because it's -3 times this 6 sin x. Please don't multiply it with the 2 also. That's one term. Do you see? I just multiply -2 times 3. And again, if I want to rearrange it, then I will rather write it like this. Okay. Now instead, as I said, that one first go down, where this one will go up, normal way. Okay. Where this one, okay, maybe I can just show you here. It would have first go down, as you can see in the sketch. But just remember, it's also moved 2 units up. And that, I'll come now to the sketch. Okay. So again, I can do my minimum and maximum, and I think this one will work better according to your formula. So the maximum will be A plus C, and don't forget again that this is A, this is B, and this is C. So if it's A plus C, then it's going to be, okay, I can go on there, okay. So it's going to be 6 minus 4, and that maximum is going to be 2. And if I want to find the minimum, it's -8, A plus C. So it's -6 plus C. So plus C. So plus C is -4, or plus -4, doesn't matter. And then it's -10. So if I'm going to write the range of Gx, then it's going to be Gx bigger than equal to -10 and smaller than equal to 2. That's going to be how I do it. Okay, but now they go on. They say sketch on the diagram. They already sketched it for you F. So I showed you this is -1. So I must find that. They didn't wrote you that scale down. I must find that middle. Now to find that middle, the amplitude, can I just show you here? So the amplitude, or to find that, I'm looking for that middle. So I can basically say, to find that, I could have said -5, okay, the minimum, or no, let's rather say the maximum minus the minimum divided by 2. That's how many units I will, to find the minimum. The middle. I'm trying to find the middle. Let's rather call it the middle. I think it's better. Okay, so the maximum is 5 minus the minimum, -1. I divide 2, and it's 5 plus 1. So it's going to be 6 divided 2. But be careful, be careful. Now you just want to go and mark that one as 3. That's not correct. What it's saying, what it's meaning, it's the middle. This is why I was writing to you the middle. So it means from -1, it must move 3 units up. So it's -1, 1, and then to 1, there is 1 there in the middle, and then this will be 2. Do you see? Because it's -1, 2, 3, and then it's going again 3. Do you see, to 5? So 3, 4, 5, again 3. So every time there's 3 units. Okay, do you see that? So I must find just that point because I must know where my other one is starting because it's also having a plus factor. Let's just make it smaller. Okay, so I know now that this green one, it goes from 2 to negative 10. Are you with me? But I must again find the middle. So how will I find that middle? So if I want to find, let's call it again the middle. I think it's good for me, the middle, where the graph starts. Okay, so it's going to be the maximum minus the minimum. And I'm going to divide it by 2. Are you with me? So if I'm going to look at this, I'm going to say, okay, so this is going to be 12 divided by 2, and that is going to be 6. Okay, so I know that this graph, okay, can I just show you first before I start doing the drawing? I'm just going to, I just want to see the maximum. I'm just checking. Maximum minus the medium, it's going to be 6 units from the bottom. So I know that this graph is going to negative 10. So if I'm going to make it bigger again, it's just because they didn't give you that scale. I know that this graph must go to negative 10. So basically, if I say that that is negative 5, okay, it's now more or less the same as I go to there. So if this is negative 5, and it's still good to work on units, I just want to work on this graph now, and this is negative 10. So just be careful, don't go to 6. It's basically that then from negative 10, you go 6 units up, and then you start basically with the graph. I just want to quickly check something here. Yeah, I cannot check it now. Okay, so if I go 6 units up, then I'm going to go and I'm going to go there up to negative 4. Did you see? Because I'm going to go 6 units up. Okay. So basically, I'm going to start there at negative 4. My highest point will be 2. My lowest point will be negative 10. And I will stop again at negative 4 there. So before you draw the graph, I think it will be good if you draw broken lines in, because it's just going to help you take your ruler and basically just go there at negative 10. So this is going to be the lowest. Okay. And this is going to be negative 4, the middle. And it's going to go up to 2, the top. Okay. And you can actually also see if your scale was good marked. Okay, so if I draw it then, I'm going to just take another color, maybe just red. So if I'm going to draw it, I'm just going to focus on that now. So I'm going to start here at 4, and then I'm rather going to take another color, blue, which is still not there. So it's just going to go up. Okay. Oh, sorry, I'm still on the straight line. So it's just going to go up, and then it's going to go down, and then it's going to go, I just want to redo that. I think even you can also mark this middle here, this middle. Okay, because then you can see. So basically, as I said, it's going to go up, and then it's there in the middle, and it's going up to there. Okay, and that's how you're going to do that. And that was the end of this questions. I want to end this video with 3 points. Point 1. All these videos refer to the y equals mx+c textbooks, the number 1 mathematics textbook used in Namibian schools. For more information on these textbooks, visit the Straight Line Publishing website. Point 2. All y equals mx+c to success textbooks are available in the NIET catalogue of the Ministry of Education. Schools can order these using their yearly budget for textbooks, with the process typically starting mid-year. Make sure your learners have a copy of the y equals mx+c mathematics textbook used by the top schools in Namibia in front of them in 2025. A final point. If you are in the position, I want to encourage you to buy your own personal copy of the y equals mx+c mathematics textbook. These textbooks are available at the following bookshops. Remember, success in mathematics comes from hard work, perseverance, and the courage to face challenges head on.